This is just a run through of the steps you need to go through to solve number 1 and number 3. There's 2 ways to solve number 3, so I'll try to cover them both without getting too confusing. To solve number 1, we need to recognize that there are 2 right triangles in the diagram, one on the left-hand side and then one on the right-hand side. The one on the right-hand side has our unknown, but we don't know any of the side lengths, so we can't set up a trig ratio. The one on the left-hand side doesn't have the unknown, but it at least has one of the side lengths. If we knew the side that they shared, which I'll label y, we would have enough information to solve for x. So what I'll start off by doing is looking at labeling my 3 sides here. So I have O, A, H, which means we are going to use the tangent ratio because I know A and I need O. So the tangent of 39 is equal to, let's say that's y over 38. We're going to look up the tangent ratio on our trig table, and we get 0.8098 is equal to y over 38. When I cross multiply, I'm going to get 30.8 equal to y. So that's this side right here. So breaking off the other triangle, maybe to make it a little bit clearer, we now know that this side, that's the altitude, is 30.8, and this angle here is 60, with our unknown on the hypotenuse. Solving for x is going to take, say we have O, A, and H. We know O, we're looking for H, so we're going to take the sine of 60 degrees and set that equal to 30.8 over x, which is 0.8660 equal to 30.8 over x. That was supposed to be a 1. When I cross multiply, I'm going to end up taking 30.8 divided by 0.8660, and that gives us our final answer of 35.6. If you need to jot that down, you might want to pause the video there because I'm about to erase this and work on number 3. Number 3 doesn't have the altitude drawn in, but that doesn't mean we can't add it to our diagram if we think it'll help. By adding in the altitude, what I've given myself is 2 right triangles. Now there's 2 ways to solve it, like I said. We can either find these 2 angles up here, or we can find this angle over here. If we want to use the 2 angles at the top, I might notice that we have a 90-degree angle and a 90-degree angle and a 50-degree angle already marked. 180 minus 90 minus 50 would give us 40 degrees right here. 101 minus 40, because the whole angle is 101 degrees, and we've already used up 40, would give us an angle of 61 over here. That's enough information to go by. I could also find it by taking 180 and looking at the big triangle and subtracting off 151, adding those 2 numbers together. And that would give me 29 degrees here. So that gives us a couple of options. We can either use the 29-degree angle down on the bottom or the 61-degree angle up on the top. If you want it to look more like number 1, you're going to use the 29-degree angle on the bottom. If you'd like it to look more like number 2, use the 61 and 40 degrees up at the top. So, breaking it up into our 2 right triangles again, we have the one on the left. I'm going to do this like number 1 again. So we have the one on the left and the one on the right. And we can break them up and solve them. I'm going to solve for the side that they share. So we have 29 degrees here, 23. I'm going to call this y because I need a different variable from x. This time we have the opposite and the hypotenuse. So I'm going to do the sine of 29 is equal to y over 23. The sine of 29 is 0.4848. And when I cross multiply, I'm going to end up multiplying that by 23, which gives me 11.2. So that's where it is on my original diagram. We could transfer that over to the triangle on the right, which has a 50-degree angle down here. Again, we're going to use sine. I have the opposite and the hypotenuse. And when I do my cross multiplication, what I'm going to end up doing is 11.2 divided by the sine of 50. Hello? And we get a final answer of 14.6. Now, just a quick note, if you wanted to solve it more like number 2, you should realize, and I'm going to write in, let's use purple, that the opposite and hypotenuse would change. Like if we used the 61-degree angle, and we knew that this was 23, this would be opposite and this would be adjacent if we were focusing on this angle up here. So just be careful to make sure you're labeling the triangle with respect to the angle that you plan on looking up on your trig table. Hopefully that's been some help.